Hello viewers, welcome to Electronics India YouTube channel. In this lecture, we are going to see about the overview of optical fiber communication system. The fiber optic communication, it is a method of transmitting information from one place to another place by sending a pulses of light through an optical fiber. The light forms an electromagnetic carrier wave that is modulated to carry the information. The fiber is prepared over electrical cabling when the high bandwidth, long distance or immunity to electromagnetic interference are required. The process of communication using fiber optics involves the following basic steps. Number 1. Creating the optical signal involving the use of transmitter, usually from an electrical signal. Number 2. Relaying the signal along the fiber, ensuring that the signal does not become too distorted or weak. Number 3. Receiving the optical signal. Number 4. Converting it into electrical signal. The figure shows the generalized block diagram of a fiber optical communication system. An optical fiber communication system is very similar in basic concept to any type of communication system. The communication system consists of the transmitter or modulator linked to the information source, the transmission medium, and a receiver or demodulator at the destination point. In electrical communication, the information source provides an electrical signal, usually derived from a message signal which is not electrical, to a transmitter comprising electrical and electronic components, which converts the signal into a suitable form for propagation over the transmission medium. This is often achieved by modulating a carrier. In optical communication system, the information source provides an electrical signal to a transmitter comprising an electrical stage which drives an optical source to give modulation of the light wave carrier. The optical signal which provides the electrical to optical conversion may be either a semiconductor laser or LEDs, light emitting diode. The transmission medium consists of an optical fiber cable, and the receiver consists of an optical detector which drives a further electrical stage, hence it provides a demodulation of the optical carrier. The photodiodes, the examples are PN, PIN and avalanche photodiode, and in some instances phototransistors and photoconductors are utilized for the detection of optical signal and the optical to electrical conversion. The optical carrier may be modulated using an analog or digital information signal. With the digital information, however, the discrete changes in the light intensity are obtained. Although often simpler to implement, analog modulation with an optical fiber communication system is less efficient, requiring a far higher signal to noise ratio at the receiver than the digital modulation. The specifications of various optical communication systems are: the first generation system, which consists of a gallium arsenic semiconductor at the operating wavelength of 0.2 micrometer or the bit rate of 45 megabits per second, and the repeater spacing is 10 kilometer. The second generation system consists of a indium gallium arsenic phosphate semiconductor lasers with the operating wavelength of 1.3 micrometer and the bit rate of 100 megabits per second to 1.7 gigabits per second with the repeater spacing of 50 kilometer. The third generation system consists of a bit rate of 10 gigabits per second with the repeater spacing of 100 kilometer and the operating wavelength is 1.55 micrometer. And the fourth generation system consists of a bit rate of 10 terabits per second with the repeater spacing of more than 10,000 kilometer with the operating wavelength of 1.45 to 1.62 micrometer. And the fifth generation system consists of a bit rate of 40 to 160 gigabits per second and the repeater spacing is 24,000 km to 35,000 km with the operating wavelength of 1.53 to 1.57 micrometer. In this slide, we will see the advantages of optical fiber communication system. Normally, the optical fiber communication system has numerous features, or some of the numerous features are wide bandwidth, the light wave that occupies the frequency in the range between 2 into 10 power 12 hertz to 3.7 into 10 power 12 hertz. Thus, the information carrying capacity of the fiber communication or systems is much higher than that the other systems. And it provides very low losses. The fiber optical cables offers a very less signal attenuation over long distance. Typically, it is less than 1 decibel per kilometer. This enables longer distance between the repeaters. The third advantage is immune to crosstalk. That means fiber optical cables has a very immunity to electromagnetic interference. Since the fiber optical cables are not conductors of electricity, hence they do not produce the magnetic field. Thus, the fiber optical cables are very immune to crosstalk between the cables, cause a magnetic induction. And the fourth advantage is interference immune. And since the fiber optical cables are very immune to conductive and radiative interferences caused by electrical noise sources such as lightning, electric motors, and fluorescent lights. Lightweight, as fiber cables are made up of a silica glass or plastic, which is much lighter than copper or aluminum cables. The lightweight fiber cables are very cheaper to transport. And the next advantage is small size. The diameter of the fiber is much smaller compared to other cables. Therefore, the fiber cable is very small in size and requires less storage space. And the other advantages includes more security, environmental immune, and less cost. The fiber cables are very more immune to environmental extremes. They can operate over a large temperature variations. Also, they are not affected by corrosive liquids and gases. Less cost. The cost of the fiber optic system is very less when compared to the other type of communication systems. Here we will see the applications of optical fiber communications. Optical fiber communications are widely used in various fields like medical, defense, government, data storage, telecommunication, networking, industrial, commercial, broadcast. In a medical applications, they are used as a light gates, imaging tools, and also as lasers for surgeries. In defense and government, they are used as hydrophones for seismic waves and sonar, as wiring in aircraft, submarines, and other vehicles for field networking. In data storage, they are used for data transmission and communication or telecommunications. Fiber is laid and used for transmitting and receiving purposes. In industrial and commercial, they are used as imaging in hard to reach the areas as wiring, where EMI is a very important issue as sensory devices to make temperature, pressure, and other measurements, and as wiring in automobiles and in industrial settings. In broadcast and cable companies are using fiber cables for wiring CATV, HDTV, internet, video on demand, and other applications. So, thank you for watching. Please like and subscribe for more videos.